All right. So yes, my name is Mayanja James, and I'm going to be looking at explainable artificial intelligence and deep transfer learning for skin disease diagnosis. So for our keywords, we're going to be looking at deep transfer learning, which is a field in machine learning that focuses on reusing knowledge obtained to train models, and artificial intelligence that is basically mimicking of human processes by machines or computers, and explainable artificial intelligence that basically looks at, it's a field in machine learning that basically looks at explaining the reasons as to why machines make certain predictions. And then skin disease diagnosis, like we're going to see, is basically any form of treatment that is given to skin patients. And convolutional neural networks is basically network architecture that basically is used for pattern recognition. Yes, so below are the group members in group 19, and yes, so let's see. Yes, so this, we're going to be looking at an introduction, problem statement, research scope, literature review. This is just a summary of what I'm going to be taking you through. Research questions, research objectives, research contribution, the methodology, and expected outcomes and future works. Well, so for diagnosis, this is the introduction. And for diagnosis is basically any form of treatment that is given to an individual from a medical personnel or any computer-based system. And in particular, here we're looking at artificial intelligence. So yes, and the skin, again, this is like one of the mega organs on our body, and it plays an essential duty in an individual's physique, for example, protection and regulation of body fluids and temperature. And like you're seeing in a description, we have someone getting diagnosis for a particular illness. And yes, so for our project, we are going to be looking at improving skin disease diagnosis using deep transfer learning and explainable artificial intelligence. Yes, so for the problem statement, skin diseases cause a huge burden in a global context, and the summaries of everything, but then also on a global scale, we're looking at roughly 1.9 billion people having skin disorders. This is just basing on research that has been carried out by various scholars, and also existing skin disease diagnosis methods are quite costly in terms of money and time, and require skill and experience, and also prone to errors. That means people can actually get misdiagnosis. And as we will be seeing later on in our literature review, the statistics of how many, or the gravity of how detrimental skin disorders or misdiagnosis can be, basically all builds relevance for our research proposal or our research topic. Yes, so this is just a summary of, let me say, problem tree rather. So we have skin disease misdiagnosis here, and on the side of a patient, which is the above part, we are looking at, it can cause anxiety in patients, that can lead, that's basically mental, an emotional stress, confusion in patients, all goes down to emotional stress, prolonged patient affliction, negative impact on patient mental health, everything just linking back to emotional stress, misperception of medicine. Again, this is also going to have a toll on a person's health. For instance, if they get misdiagnosis, that means they get the wrong medication, and wrong medication equals literally more diseases, more complications, and then also they can also spread the disease to other people who may not have the disease. So on the side of the diagnoser or the doctor or the medical personnel, we are going to be looking at it being time consuming to just diagnose just a particular disease. We also have lack of time with patients. They rarely have long interaction time with patients, improper testing, nature of the test. We're looking at also sometimes, or in most cases, equipment, like we will see in our literature review that the equipments are high tech and are practically expensive, and not every medical personnel uh, can actually afford, or particularly hospitals or facilities can afford all these devices. So yes, let's see, wait. All right. So the research scope is practically going to be, we're going to be focusing on 10 skin disease classes, that is melanoma, eczema, acne, rosacea, psoriasis, contact dermatitis, to mention but a few. And we shall be strictly looking at using deep transfer learning, convolutional neural networks, and explainable artificial intelligence techniques like GradCam, LRP, and GraphLine. So yes, that's practically what we're going to be looking at. And then for our literature review, that particular scholar carried out research and found out that over 1.9 billion US dollars goes into wastage, or probably not wastage, but probably it goes into just, let me say, it's injected into trying to solve misdiagnosis problems, just basically all around the area of skin disease misdiagnosis. Now that is just in the United States alone, and that accounts for roughly around 40 to 80,000 skin disease cases that have been registered in the United States alone, and that was research carried out by RHA, and also the NIH, which is the National Center for Biotechnology Information, shows that the cost of treatment for people with skin disease or skin cancer is over roughly $1 billion US. So this is all just research carried out by different organizations and bodies. And then also, let's see, in addition, the World Health Organization research conducted in 2001 on diseases that are burdensome worldwide shows that there's an analysis that most of these diseases were actually skin related. Yes, so in terms of the research questions, we shall be looking at how can deep transfer learning be used to improve predictive accuracy in diagnosis of skin disorders. How can explainable artificial intelligence be applied to the field of dermatology to increase adoption of artificial intelligence methods in general? How can deep learning be used to automate diagnosis for skin diseases using imagery data? To what degree can explainable artificial intelligence justify deployment of a skin disease diagnosis model for public use by dermatologists? Now, just to summarize all this, we're trying to, let me say, we're trying to augment a process that critically is let me say detrimental. It's very critical when it gets to health. We need to be precise in diagnosis, and again, like I said, we are augmenting the processes that are already existing. We're not trying to replace them, but we're augmenting these specialists, and that's the whole reason as to why we're providing. We're going to be employing deep transfer learning models, and we're going to be using explainable AI to validate these models. Again, yes. So for our research objectives, we shall be, we aim at designing a trained model that will diagnose skin diseases. And then for specific objectives, we plan to process and prepare the dermatology data set for model training. Now, obviously, we shall be collecting this data from various sources like online sources, and maybe some of them we shall collect from local clinics around in Uganda, and try to train our model just to improve or to increase on a data set. So we also aim to test and evaluate deep transfer learning models, hence precisely determining how good the model is. And our sample will be spanning from 1 to 10 disease data classes, so skin disease data classes. And then we also aim to deploy an interpretable, yes, that one, explainability using XAI, that is explainable artificial intelligence techniques like LRP and GradCamp for understandability and landscape disease imagery features. Yes, just to throw more light on that, we shall be trying to explain the reason as to why our models are making those predictions. That's gaining more insight in what features it probably could have looked at, and again, improve on our knowledge on how we understand and approach skin disease diagnosis. So our research contribution, our main contribution will be practically using explainable, or majorly using explainable AI techniques and deep transfer learning to validate our models. That is, we aim at trying to build trust for our models. I mean, why would we have to use a model that we can't understand? And practically, the process is simple. We'll obtain information or data from the world, and it's going to be translated, or we will use the data to train a model, and then we'll use explainable AI to provide interpretable and explainable information or data that can be understood by users, and it shall be represented in form of graphs and in a way, or clickable, or UIs that are understandable by human beings. So the methodology is practically, we're going to be using CNNs, that's convolutional neural networks, transfer learning models, and VGG16 and explainable AI. So we shall, again, using this diagram, I'll simplify the explanation. We shall be feeding our models with the model that we will be obtaining or training. We shall be feeding it with imagery data, and this data will be pre-processed, and okay, practically it will undergo resizing, pixel normalization, image augmentation, and then on top of that model, we shall add another model, which we shall, an interpretable model, which we shall use to actually, let me say, explain the features that the other model is actually looking at. So we shall just be mimicking a model just to look at what features it looked at to make a particular prediction. So since most of these deep transfer learning models, or CNNs, or yes, since most of them are complex, that is practically the reason as to why we have black boxes. So we're just trying to explain the black box using explainable AI, and then we shall be able to represent this using DRADCAMs. Yes. So expected outcomes, we expect to deliver a fully trained and tested deep learning interpretable model that is capable of diagnosing various skin disorders highlighted in our research scope. Yes, so a GradCamp implementation and integration into the model, hence providing explanations for each prediction made by the model. Yes, so for future work, we shall be, we plan to implement more explainable techniques using Python or in Python. And then we plan to also contribute to the open source communities. Yes, so I guess that is it. Thank you for listening.